Let's just move that away. Okay. So welcome to growing the PHP core one test at a time. My name is Florian. You can find me on the internet usually at Real Flow Control. I'm a PHP developer since a long time now. I'm working fully remote for a company called Raiffeisen Networld. We're building a B2B platform for the German-based agricultural sector. I'm an open source contributor. I'm only contributing, like not only, but I'm mostly contributing to open source tools that I use in my day-to-day life. That would be, for example, GraphQLite, PHP itself, and also the PHP core. And I'm doing so although I'm married with 5 kids. So that being said, if you do not have at least 5 kids at home, you'll probably be able to find some time to contribute to open source. Okay, so why are we here today? I'm here and I'm giving this talk and I'm telling about testing for PHP because I want to get people into write tests for PHP and to contribute to open source. So the question is, what is my motivation? What was my motivation to start writing tests for PHP? So basically, I got introduced into PHP in September 2000. That's 21 years now. And my entire professional career is based on PHP, with a few exceptions in exchange for money. But I would say that 90% of the time, I got paid to solve problems, and I did so by using PHP. So everything I earned, everything I've done in my career is based on the fact that PHP exists, that people built PHP back then, and that people still do. So it was about time to give something back to the community. And in the year 2017, I stumbled onto the PHP Test Fest. The 2017 edition was the last edition so far. So for whatever reasons, I don't really know, there was no new Test Fest in the following years. And the 2017 edition was organized by Ben Ramsey and Sammy K. Powers. You've probably heard of them. And the idea was to write tests for PHP. And that was also the first time I stumbled on an idea how I could contribute to PHP itself, because most of the time before I heard of the possibility to write tests for PHP in PHP, I was always thinking that when I will contribute to PHP, I would have to write C code, or I would have to define a new language feature and make an RFC for that and contribute the source code to actually implement that feature. And that seemed like a huge step. So just writing tests for PHP in PHP itself does not look like a big step. So I started to write tests in the PHP Test Fest 2017. And what you need in order to be able to write tests for PHP is you need to compile PHP from source code. And so basically what you do is these steps. The PHP source code itself is on GitHub. So you can just clone that repository. If you want to make a pull request later, I would advise you to fork, because I think that everyone here, including me, do not have push rights to the PHP source repository. So just clone that, fork it, clone that one, then you can run build conf, configure, make, and after that, everything is there. Sadly, I cannot do that live today because they changed something in the configure script. So basically, when I would run the configure script again, I would have to recompile everything. That means that we would just stare on a screen for like 5 minutes. But nevertheless, I prepared all of these things, and I can show you in the terminal that I've actually compiled a fresh version of PHP. So let me just zoom in. As you see here, this is already PHP 8.2. So basically it's not 8.2, it's just the master branch. But as the PHP 8.1 release candidates have been created already, the PHP 8.1 branch has been forked from master. So in the master branch, there's everything going on for PHP 8.2. And you can see that I compiled that today, fresh from today. Okay, so when you have compiled it, the next step would be to just execute the test and run what's there and see how this goes. So what you can do to run the test is just make test. But since PHP 7.3, you can give the test PHP args and give it an argument to run multiple test workers. That's nice because you will see in a second that there is quite a lot of tests in the PHP repository. And by giving the -j argument, it will start as much, the argument as we have in the -j nprog will start as much concurrent test workers as you have CPU cores on your machine, so it will go a lot faster. And if we execute that, you see a lot of tests scrolling through. Probably the video stream will be all choppy now and full of chunks, but what you should be able to see when it's all done, I'm going to scroll through. You see a lot of pass, you see some skips, you see one fail, I think. And in the lower left corner, you see that there is currently run test 9,000 of 12,000 in 8 of 8 concurrent test workers. And so we can just wait for it to finish. In the end, it will slow down a bit because there is some tests that are not able to run in parallel. Those tests will be executed at the end. Now you see that there's only 3 of 8 concurrent tests, or that it's 2, then it's just 1 that will finish all the tests that cannot run in parallel. And at the end, it's giving us a summary and asks us if we want to send the report. And at this point in time, we do not want to send the report. So let's scroll a bit back. So what we have here is we have the test results summary. And we see that we executed 11,845 tests in just 52 seconds. I would say that's pretty amazing. I've seen testing libraries that take ages if they just execute like 100 tests. In this case, you also see that there is some skipped tests and skipped extension. We come to that later because overall, the testing library tells us that there are nearly 70,000 tests in the PHP repository, but only 11,876 are being executed. So what we also see, this is just the plain numbers. What we also see is we see a summary of the expected fail tests. So there are tests in the PHP repository that are at this point in time expected to fail. That's mostly something where we, or where you find out what's the problem, or that there is a bug, but you don't know how to fix it. So you can now create a test and write a reason why you expect it to fail. There is a lot of daytime tests that currently are expected to fail, but you can also see that there is this test that fails, and the usual reason is a link to a discussion that's going on somewhere. In this case, there is a discussion about this test going on in the PHP internals mailing list. Then you have a summary of tests that actually failed. So there is this test, a test that disk free space and its alias disk free space functions have whatever basic functionality is in that case. Looks like it's not working. And then there is a warning. In this case, it is a warning because it was expected, this test was expected to fail, but it didn't fail, it succeeded. So it looks like the upstream bug is fixed already here. And then in the end, you get this nice text asking you to send this report to QA, to the QA list. In this case, as we're giving a presentation, we're not doing that. So that's how that's the summary of the test. And now we've seen that we actually have a PHP binary that's 99.7% good. Let's go to the next one. So the next question would be, how does such a test actually look? So all these tests that have been executed, those 11,000 files, roughly 11,000 files that we have, every test is a single file. And these files look like this, what you see here. So a PHP file is just a bunch of sections in a text file, several sections. There is a lot of sections. So the first section that you have, and it's mandatory, is the test section. This is just the name of what you are testing. So in this stupid example that I have here, we are testing the string length function. So just the name is just test, and then string length functions, whatever it's printed on the CLI when you run the test. If you need more description, if you want to write more stuff, or if you need to describe more stuff, there is a description section that's not printed out when the test runs. But this is a place where you can write more description of what you're doing in this test. So if someone looks into the test, they can find this description block, but it's not printed out anywhere. Then there is the skip if section. The second section, the skip if section, this is optional, but I noted it here anyway because a lots of tests that you can find in the PHP core have the skip if section. The main idea here is that it doesn't make sense to execute a test for a section that's not compiled or that's not loaded currently. For example, later in this talk, we're going to write a test for the setlib extension. And if the setlib extension is not compiled in by default, you need to explicitly activate that. And if the setlib extension is not installed or not loaded, it makes no sense to run the test because it would fail anyway. So we can just skip the test. So usually in most of the cases, the skip if section looks like that. You have a if not extensions loaded, whatever it is, that echo skip. And technically it works like this. The PHP test runner executes that snippet and checks if the output starts with the string skip. And if that's the case, then it will just skip the test. The next section that we have is the file section. The file section then is the actual test that you do. So testing in the PHP file works as follows. You have a file section that is being executed by the PHP parser. Whatever you want to test, you just do there. You have to give something out to stdout. So in most cases, you just see a lot of var dumps everywhere. And then the output of the PHP script in the file section is matched against the content of the expect section. It has to exactly match the expect section to parse. The alternative that you have, if you, for example, in this case, we expect string lang hello world to return a int 12. If we would say that the 12 might be variable, it might be another number, you can use expect f as a you can use expect f instead of the expect section. And then you can use substitution tags that you probably know from printf. So you could, in this case, write expect f int brackets and then %d. That would render the test useless in this case, but it would make the test also pass. And then the last section, you do not have that all the time, but in some cases you have a clean section. In some PHP files you find a clean section. The idea is just to clean up after yourself. The clean section will be executed if the test was run. Doesn't matter if it passed or not, but if it skipped, the clean section will not be run. One thing that you need to know here is that all these sections are run in isolation. So the test runner actually splits those sections into different files and then executes the PHP process with the skip if section. Then the process dies, then it executes the file section, then the process dies, and then it executes the clean section. So if you store, for example, let's say a file name in a variable in the file section, so you create a temporary file and you want to clean that up in the clean section, that variable doesn't exist anymore. So you need to do other stuff, like use a temp file or something that the temporary files will be cleaned up after the process dies. Or in the clean section, you have to know from the test, how you write it, that there should be a file, and then delete that one. So now that we know how a basic test looks like, we need to find something to test. When I started to write tests, there was gcaf.php.net. That was a bit easier because you just had a web page with a code coverage report. For reasons I don't know, it's a bit more complicated today. So basically what you need to head over to Azure Pipelines. So all the PHP tests that we have just run here, including the code coverage, is run on Azure Pipelines today. And we can go over to Azure Pipelines. You need to find a scheduled build. Let's just go to Azure Pipelines. You can find the link on the GitHub action page for PHP. Then you need to find a job that has been scheduled. So in this case, there's a lot of batch jobs. But here we can find a scheduled job for master. and you see that failed. You can just go to that report, and for all the scheduled jobs, you find a code coverage tab. So you can go to the code coverage, and here you see the summary of the code coverage report. So overall, we now know that PHP has a line coverage of 76.7% and a branch coverage of 55% roughly. And then you see here all the files, the directory, in this case, the send directory, and then the send API C file, and you see the covered, uncovered, coverable, total lines, and all these information about the code coverage for that single file. And you can scroll down, and you see that's a pretty big list of files to be covered or to be tested. And in some cases, you see that there's only 11% code coverage, but the PHP debug as API is pretty hard to test. So there's the thing. That's how you can find lines that are currently not covered. So what I did back then, let's just close this one. What I did back then is I was lucky to, I could just head over to gcaf.php, and I had another few, but pretty much the same idea. I was able to see covered and uncovered lines. And what I found out that there is the setlib extension, and the setlib extension had this PHP function that's called setlib get coding type, and it was all red. It was not covered at all, and I found that one, and I was like, "This is a low-hanging fruit," because when you look at this, I mean, this is C code, okay? But even if you're just a PHP level and have never read C code, you can basically grasp what's going on here. This is just you call the setlib get coding type function from PHP user space. Then it does a switch on a variable, whatever that is, and it will return gzip or deflate or false. So this is everything there is, and I was super happy that I could find this like 7 lines of code that I could easily test. What do you do when you find such a thing? You can go to php.net/setlib get coding type and to the documentation of that function and check out what it actually does. So what the bigger picture is of that function. And the bigger picture in that case, if you don't know, is that PHP can do magic output compression for you. So when a browser or a client sends an HTTP request to your PHP server, and in the HTTP request, the browser sends an HTTP accept encoding header, they can tell us that they want or that they accept an HTTP response being gzip or deflate encoded. So they're just telling us by sending us the header that they are going to be able to decompress if we send them a gzip or deflate response tree. And on the PHP side, on the other side in PHP, there is a ini setting, and we can set that one to true if we allow PHP to react on that HTTP accept encoding header and actually do output compression for us. So in your user space, in your code that you're going to write, you don't need to do anything in order to get output compression. You just need to activate that ini feature, and PHP will do the rest magically for you. And by calling the setlib get coding type function, you from user space, from PHP land, can ask the PHP process if it will do output compression or not, and even it will tell you if it's gzip or deflate when it will do. So what we need to do is we need to write some tests for it. The test that we would need to write would be for the absence of the accept encoding header. So get an HTTP request and there's no accept encoding header. And we assume that this ini setting that's called setlib output compression is turned on. Then it should return false because the client is not accepting any encoding. If the client tells us it's accepting gzip, the setlib get output compression function should return gzip. If it tells that if the client sends an HTTP accept encoding header of deflate, setlib get coding type should return deflate. Or also an option, the browser or the client might send us something in the accept encoding header that's not gzip or deflate, like just like any string, then we also should return false. Function also should return false. And then also we need to test everything with the setlib output compression ini setting being on and off. So I would say we'll do that. I prepared one file, that one, and this is the basic test I wrote. So what we have here is we have our test section. In this case, a bit more descriptive than in the other example. It's we are testing setlib coding type with a gzip encoding. The setlib extension is not bundled by default in PHP, so we need to check if the extension is actually here, if it's actually installed or activated. So in this case, just if the extension is not there, just print skip, and that's it. And now we come to the test. So first of all, we need a mechanism to somehow inject the HTTP header, because we do not have a real HTTP request here, but we need to inject that HTTP accept encoding header. So what can we do is there is this $_ server super global where we can read all the HTTP header from. So we can just write $_ server HTTP accept encoding, assign gzip to that, and then we fake the HTTP request with an accept encoding header of gzip. And then to make it explicit, we set the setlib output compression to off. Then we call the setlib coding type function and just var about whatever that gives us. Then we turn setlib output compression to on. And then we var about setlib coding type, the second call. And in the first call, we would expect it to be false, because the browser stated that it accepts gzip encoding, but we in PHP have actually disabled this feature. So PHP should not do any output compression. But when we turn the feature on, PHP should actually do output compression, and it should use gzip for output compression. So that's the test we created as a first try. And I would say we just executed one and see how it goes. If you want to run a single test, you can just use the make file that's in the PHP source folder. So it's just make test, and then you can give it the tests argument and tell it what test to run that single one test. So if we execute that, fingers crossed, and see how it works. Okay, that doesn't look too good. So you see a lot of information about you about the PHP API versions that it's actually using to test this. Some meta information, your var grind is not used, and all this stuff. And then we see a red fail that we do not want to see here. So we have just run one test. That one test failed, but at least it failed pretty fast. So that's the good thing here. The question is now what happened. With this information, we don't know what was the problem, why did it actually fail. So what you can do is the test runner will create a bunch of files for us. So when the PHP test runner executes that test, it will produce a number of files. And when the test fails, it will not clean them up. So they're just here. And what you can do is you can look at the one.log file. And in that file, you see the expected output and the actual output of that script. So we see that the first var dump with the call to setlib get output compression, we expected a bool false, so we got the bool false. And in the second case, we expected something different, but what we got was a warning. So the warning states that we did a call to any set, and that one stated that it cannot change the setlib output compression because headers already set. Okay. Let's go back to the test file. So if you go back to the test file, the warning that we got was from this line, from this ini-set call. So it looks like we're not allowed to change that. And if you think about it in the background, it totally makes sense, because what happened here is the following. The browser stated that it's going to accept gzip encoding. We stated that we do not want, the PHP is not allowed to do output compression, so we're not doing it. And then by calling this var dump, what we do is we are starting to send a response to the client. What's happened magically here for us is that PHP, before the first response is being written, PHP will magically send the response headers. And because we stated that we do not want to do output compression, PHP will not send a header indicating to the client that we're using gzip, but it will instead of send to the client that the content is just text plain. So there is no option for PHP anymore to, like when we call any set and change the output compression to on, there is no option for PHP anymore to tell the client that despite we stated that we're not doing output compression and the first few bytes are not compressed, the rest now is compressed. have luck parsing that. So this is just not working. So what we know that you probably know that from the session start. As soon as the first HTTP response headers have been sent, there was no option for you to send any headers anymore. So what we can do is we can just store that output in a variable and just bottom out the variables after. So we can just write, let's say, just store it in a, let's say $off variable because we expect it to be off, and then there, say a $on variable. Probably don't need that, but it's easier that way. And then we run var dump and another var dump. And that should probably do the trick, because now when we do the second counter instead, there should not be any output. So we have the we have gzip set, we have it turned off, then we call setlib coding type, it should be false. Then we do the init call, and then setlib coding type should be gzip. So let's give it a try how it looks now. Okay, that will execute exactly that one test that we just changed, and it still failed. So let's have a look at the log file. We already know where to look. And this is interesting because now we do not have any error messages, any warnings. There is no nothing. It's just like it failed because it didn't work. Okay, that one is tricky. That's really tricky because when we check the file, it looks like we've done everything correct. And actually, we have accept encoding set to gzip. The output compression is turned on. It should actually behave like this, but it's not. So the problem here comes to the complex thing. Now you have two options. The one option is to have a look at the source code. In this case, I can show you the source code. That's in x-setlib.c file. And let me just quickly jump to that function. Here we have it. This is the setlib coding type function that we had in the screenshot earlier. And the screenshot was from PHP 7.2. This is PHP 8.2. So that didn't change. It's still the same thing. So when I was looking at this, I knew that okay, that compression coding variable here that's being switched upon, that should be written somewhere. Someone needs to write to that some value. So I skipped through the source code and I found these two lines. This is the only two lines in the entire setlib extension that a value is being written to that compression coding variable. So we started to analyze what's going on in this if statement here, because somewhere in this if statement, it's looking, doing something, and then writing gzip or deflate onto the variable. And in my case, it looks like this doesn't work. So what's happening here is I found out that basically this, I have no real clue what this does. It's just checking if whatever track var server here is an array, or, and this is the more interesting thing that I think I understood back then, was that it's looking for a underscore server auto global. So basically it looked like to me that this line checks if there is a $_ server super global. And the next thing, the next line is that it's writing to an enc variable and does whatever that is. And this, a bit of background, PHP arrays are basically hash maps. So what this does every time you access a PHP array with an associative key, it basically creates a hash from that and tries to find that hash in the hash map. So that's exactly what's going on here. There's a lot of macro magic in PHP, but basically what happens here is PHP tries to find an HTTP accept encoding key in the $_ server superglobals. The problem that I had while reading this was I was like, when I read that and partly understood what's going on here, I was even more sure that what I've written in source code should actually work. So that was a dead end to me. So the next option that you have is you can go over to phpc.chat, which is a chat room for the PHP community. you find Derek Rethans there. You can find Ben Ramsey and Sarah Goldman and all these people. And I asked them about the problem that I had, that I wrote this test and that for some reason PHP just didn't behave like I expected to be. And I found out that part in the setlib where it's writing to that variable, and that I interpret that as I'm correctly right with what I'm doing, but somehow it's not working. And they couldn't help me. So what they told me is one thing. What they told me is the following. When you're looking a bit into PHP memory management, then you're going to find out that PHP is basically everything in PHP is copy and write. So when you pass an argument to a function, basically you're just passing a pointer to your original value, and as long as you're not changing the value of the variable, you are working on the original copy of that. But as soon as you write to that variable, PHP will copy a clone for you that you're going to work on. And exactly the same thing is also true for all PHP user accessible superglobals. So the $_server variable, $_get, $_post, whatever you have, all those variables are, with everything else, copy and write. That means what's happening here is in this line 7, when we write the string gzip to the HTTP accept encoding in the $_server superglobal, what PHP does it creates a copy of the $_server array for the PHP user space to work on, and PHP itself will always work just on the original and never on the copy that we created. So that means that we cannot change the $_server or the HTTP request headers from the user space. So it looks like there's a dead end here. But there's something that you can do. There is, as I said earlier, there's a lot more section than just these few that I showed you. And there is, for example, a env section. So what we can do is we can inject the that HTTP header as an environment variable. So basically, all the HTTP headers that are being passed to the PHP process are passed through the environment. So we can do the same thing here. And that means that now, hopefully, PHP in core will also have the HTTP accept encoding key in the $_server superglobal set to gzip, and we can finally get the test running. So let's try it out and hope that I didn't make a mistake here. And let's run the test again. Oh my God, and we see it still fails. But let's have a look at what went wrong. Oh my God. Okay, so that does not match. And whatever that is, it's crazy. But let's go through the test. What could have happened here? So we're sending an HTTP request. We fake an HTTP request to PHP, and we claim that we understand gzip encoding. Then we turn it off, and then we turn output compression on, and then we are doing output. So what might going on here is that PHP is actually doing output compression. So that's a problem because we cannot, if that's the case, that's a problem because we cannot match that against the expect section. So technically, yes, we could write them binary garbage in the expect section, but that's probably not how it should be. So, but what we can do is we can just turn the output compression off again after the second call to select encoding type. And if we turn it off, and we haven't sent any output, it should be able to turn it off, and then we should hopefully have a successful test. Let's run it and see how it works. And it passes. So we finally have select encoding type with gzip encoding passed. So so here's a screenshot of the version that you can find in the PHP source code. Also created the versions for HTTP accept encoding being set to deflate no HTTP accept encoding header at all, and HTTP accept encoding being set to some stuff that the setlib currently doesn't exist. Then I created a pull request towards PHP master branch, and that got accepted a few days later. And in the PHP 7.3, in the code coverage report, I could see that those lines were actually covered. So now we have, you've seen that we have 2 calls to setlib coding type. We have 4 test files. Basically what we have is 8 calls to setlib coding type. So all the tests that we had in PHP 7.3 were just these 4 test files that I've created. So in the end, what did I learn? So first of all, what looks simple might be complex. In the beginning, I saw these like 6-7 lines of a switch statement, and I was like, this is super easy. You can finish that in some minutes probably, but it took me quite a lot of time in the end. But I learned also that superglobals are copy on write. I didn't know that before. I know that like all the variables that you pass to functions and methods are copy on write, but I didn't know that this is also true for the $_server and get and post superglobals. But now I know that that's the case, and therefore this makes the HTTP request that you actually get, it makes it immutable to the PHP core. And I started remembering that in a lot of cases, I was actually changing stuff in the $_server array because some process later in the line was reacting and hoping that in $_server, whatever HTTP request, there was something being set. And now I realized that this was probably a bad idea, because like my code in PHP will actually react on that, but not the PHP code itself. Another thing that I learned is that there are modify handlers for any settings. We've seen earlier the second call to any set. The second call to any set, when we disabled the setlib output compression, was throwing a warning. That's basically all those any settings are defined in the setlib extension in that case. So every extension defines their any settings, and they also define a function that has to be called when the any setting is changed. Then there is a function being called, and that checks if headers have already been sent. And if they have been sent, it will throw that warning. And if they haven't been sent, it will do some initialization and stuff and fill that variable that we need in order that to setlib coding type actually work for us. In first place, I always thought that calling any set would just like set a variable to a certain value, whatever it is, and that's just, and for the future it will react on that, but it will not actively do anything. But there's a lot of stuff going on if you call any set. So that teach me to actually check on the return of the any set function call, because it might fail. So that was what I learned. But the other question that you could ask is, what do you gain? Like when you actually start writing tests for PHP. So first of all, with everything where you start writing tests, PHP will be more stable and more reliable. So it will not happen that a function that you have written tests for might flip in the next release, because there are tests that nail down how the function has to behave. The next thing is what you learn is you gain a deeper understanding of how PHP works internally, and probably even about extensions that there are in PHP that you probably haven't seen at all. In my case, what was super handy is that I, by searching for another stuff to write tests for, I found about a zip archive class. I hadn't worked with zip files in PHP since like 10 years or 12 years. And the last time I've worked with zip files in PHP, I created a class that basically wrapped the zip and unzip binaries with a system call to zip and unzip files. This is a horrible thing to do. Don't do that, because today we have the zip archive class and it does all the magic stuff for us. And the funny thing about that is I created the test for the zip archive class, of some of parts of the zip archive class, and committed them and made a pull request. And a few weeks later, I had a new task on the board that a customer wants to upload a zip file with a CSV in it and some JPEGs. and that should be imported into some data store. And I was like, funny thing, I know that there is a zip archive class and I don't need to write a wrapper for zip and unzip binaries. Good thing. And the other thing is the PHP test format that you've just seen today. This is not some niche thing that's only used in PHP core itself. PHP unit has a test runner for PHP files, and a big part of the PHP unit tests is written in PHP. So that's basically how I also became a PHP unit contributor. And in the end, contributing to PHP unit brought me my first elephant. And there is one thing that you gain if you start writing tests for PHP, make a pull request, and actually commit a test to PHP core, is that you can tell everybody, if they want to hear or not, that you are a PHP core contributor. That's all, folks. Thanks very much. And last thing, if you're actually interested in writing tests for PHP, you can head over to phptestfest.org. The page is a bit outdated, but only 4 years outdated, so it's still a lot of true. There is qa.php.net. This is where you find the quality assurance page of PHP. There's also the original definition of the PHP files, and you will find a lot more sections there that you can use in your PHP tests. And then there's dotbox.org, which is my blog. There you can find a blog post about that topic with the same title, Growing the PHP Core One Test at a Time. And as an added bonus, you will also find a section about how you can create your own code coverage report for the PHP Core. Thank you very much.